Good morning to all. I welcome you for the lecture series in Production Technology course. Today we have a very interesting manufacturing topic, welding. It is the art of joining metals. Welding is a fundamental process in various industries from construction and manufacturing to automotive and aerospace. It involves fusing metals using heat and pressure, creating strong and durable joints. Any two parts to be joined, we have two kinds of joint. One is permanent joint, another one is temporary joint. We all know temporary joint is made up of nuts and bolts. We can easily assemble and dismantle the same. But permanent joint is a joint where two metals are being welded, metallurgically fused, and that cannot be separated after the joining process. We have various types of welding process. One is arc welding, MIG welding, TIG welding, and spot welding. So arc welding utilizes an electric arc to melt the metal, forming a weld pool, commonly used in construction and fabrication. MIG welding uses a wire electrode and a shielded gas for a fast and efficient process suitable for various metals. TIG welding employs a non-consumable tungsten electrode and an inert gas, ideal for precision and high-quality welds. Spot welding, a resistance welding technique using electrodes to create localized welds, commonly used in sheet metal fabrication. So normally, most of the process we use arc welding process. For automotive parts, we use metal inert gas welding. For aircraft manufacturing, the sheet metals are welded with TIG welding, which employs a non-consumable electrode. And the example for spot welding is our two-wheeler silencer or muffler, we call it as technically, where baffles are welded inside the muffler using spot welding process. So safety considerations in welding, we have fire hazards. Welding produces intense heat, posing a fire risk. Always have fire extinguishers readily available. Protective gear. Wear heat-resistant gloves, a welding apron, and sturdy footwear to protect yourself from burns and sparks. Eye protection. Wear protective, appropriate safety glasses or welding helmet to shield your eyes from harmful UV radiation. Gas hazards. Welding gases like acetylene and oxygen can be flammable and toxic. Use them in a well-ventilated area. Selecting the right welding equipment, power source, choosing a welding machine with appropriate amperage and voltage for your application. The shielding gas, if using a gas shielding process, ensure you have right type and flow rate of shielding gas. Torch and electrode, select a torch and electrode compatible with your welding process and the metal you are working with. Safety gears, invest in high quality safety gear, including a welding helmet, gloves, and protective clothing. Proper welding technique and form, preparation, arc striking, travel speed, cooling. These are all the four things to be taken care of. So we have basic joints, four types. That is butt joint, joining two pieces of metal end to end, creating a straight line. Overlapping two pieces of metal, creating a strong connection, we call it as lap joint. And T-joint, joining two pieces of metal at a 90-degree angle, forming T-shape. And corner joint, joining two pieces of metal at a corner, creating a right angle. Some common welding defects that occurs naturally. It is inevitable that we can either reduce or eliminate certain things. Cracks, porosity, undercut, and a lack of fusion. So the future of welding advancements and innovations are robotic welding, where robots are employed for welding process. Automated welding systems enhance efficiency, precision, and safety. Laser technology enables high precision welds and complex designs. 3D printing, additive manufacturing revolutionize welding by creating intricate metal structures. Sensors and data analysis optimizes welding process and improve quality control. I hope you understand the basic process of welding. We'll meet you in the next lecture series. Thank you.